Okay, we are going to go over math packet number 11. Our first problem is in April, 20% of the customers at Auto World bought blue cars. Of those customers, 15% chose gray interiors. What percent of the customers at Auto World did not choose a blue car with a gray interior? Well, if we know 20% of the customers bought blue cars, 20% out of how many? 100%. So we know it's out of 100%. So of those 20%, 15% chose gray interior. So we need to think, whittling it down from that 100% down to 20%, and of that 20%, 15% of them. So what percent of the customers at Auto World did not choose a blue car with a gray interior? So if you know your 100% of customers, and then 20%, and then 15% of that 20% is how much out of the whole 100%. And you need to know which ones did not. So that is our full 100% from one end to the other. We need to know from here to here. So we need to know 15% of 20% of the 100%. And then you want the other side of it. So if you can figure out what 15% of 20% of the 100% is. So we've got 20%. So this was 20%. We want to know what 15% of 20% is. What does of mean? Multiple. So can you find 15% of 20%? So if you can find that percentage, subtract it out of the 100%. Mr. Graves. Other room. Aiden. You're looking for Aiden. So find the 15% of the 20%, and then you subtract that away from the full 100%.
Yeah, thought it was 15% of 100%.
Yeah, it's not though. It's 15% of the 20%.
Oh, okay, that makes more sense.
Tina left her house at 9 a.m. to ride her bike down a very long road at a speed of 12 miles per hour. At 10:30 a.m., her sister Vanessa left the house on her bicycle and tried to catch up to Tina. Hello. He is right here. Woohoo! He sure can. Thanks. Bye. Go pick up. Oh, Gavin. Did Mrs. Gregory talk to you? Okay. Mom sent an email earlier. We got today for baseball game, so she will probably be surprised at the end of the day that we're on that. So she dropped off your uniform. So you can go select your uniform. You will be coming up to the game. Huh? Playing on a different team. Okay, so Vanessa rode at a speed of 20 miles per hour. At what time will Vanessa catch up to Tina? So we had something similar on our last one with the trains leaving, and when did one train catch up to the other train? So we know that at 9 a.m., Tina left at 9 a.m., right?
Mm-hmm.
So then we've got 10 a.m. and then she leaves at 10:30. Vanessa leaves, so she leaves and she's starting at 9 a.m. So at 10 a.m., how far has Tina gone? If she's riding 12 miles per hour. Yeah, she's gone 12 miles. So she left, she was at 0 at 9. At 10, she had gone 12. So at 11, how far had she gone?
24.
So now Vanessa's leaving at 10:30. So now, how are we gonna do this? Because one's at the 30 and one's at the hour. Because we know that Vanessa at 11:30, she'll have gone, how fast is she going?
30 miles. 20 miles.
She'll have gone 20 miles, right? Well, if she's riding at 20 miles per hour.
I thought you were talking about 11.
No, you're right. At 11, she would have gone 10, because she would have gone half. Because 11 is halfway between 10:30 and 11:30. So we can figure out that 11, she's gone 10 miles. So do we have to keep going on the half hour then? No, because we know that an hour later, she's going 20 miles an hour. So now we can just bring them both to that 12 o'clock time. So add on 12 miles, add on 20 miles, and you can bring them to the same hour. Did that make sense? Oh, and you looked a little confused. Do you see how I got 11, 12, and 24?
Yeah.
Do you see how I got the 0? And then I got the, if this was 11:30. This was 20.
Yeah.
So halfway at 11, she would have gone half the distance. So she went 10 because that's halfway. Briggs.
Oh, does the answer have to be like exact timing or just
At what time will Vanessa catch up to Tina?
like exact time or just like rounded?
It can either be the half hour or the hour. Which one is closer to what you think it would be? Okay, Colin, come up here and show me. I have not worked it out yet, so let me work it out for an answer to give you a more specific answer. Do you have ones for me to look at? Yes. I'm gonna have to work it out. And then I'll get back on the specific type of answer. So I will work it out later and I'll get back to us on that one. But at least we have a good start on how to figure it out. Okay. Next one is our 5-card challenge. We know that. Find the area of the entire figure. So you need the area of the entire figure and then the area of the shaded regions. Oh, look at that. What can we use to find this side? Cole?
Wait, of the shaded? Or of the
So if we know that this is 6 and this is 6, what really cool thing did I just teach us last week?
The 6 times
A squared plus B squared equals C squared. So if we did A squared plus B squared equals C squared, we can find the length of O. You know, it doesn't look like they're the same size though, does it?
Wait,
But they would have to be.
Oh yeah.
Because they're all 6, 6, 6, 6. So it has to all be equal. So if we find what C is, we can figure out the area of the white shape. Subtract that out from the whole area. What were you saying, Katie?
No, I just read.
Naveen?
Couldn't you also do the area of the, find out the area of the triangle?
What do we need to know to find the area of a triangle?
Base and height?
Yeah. here's my base. How are you gonna find the height?
Oh.
Yeah. I thought of that. I thought, oh, well, find the area of the triangles and then add them up, but I don't think there's a way that we can find the height. So that's why I went to the a squared plus b squared equals c
I'm
squared.
so lost.
So, Maddie, remember the binder sheet that I gave out on Thursday? Pythagorean Theorem. A squared plus b squared equals c squared. These two legs are the same size. That's our legs. So we can find c.
Wait, but then would you square C? Because
So
you find the square.
if we know this length, it's going to be the same as this length because these are all the same size. So if you know length times width, you can find the area of the white, right? Length times width. And then subtract that out of the whole square. Chase?
Could you just find the square of each side and then divide by 2? Because you half of the square.
I don't know.
Okay.
I don't know. I will do it my way and you do it your way and we'll see if we come up with the same answer. Okay? All right. Oh, our figures, finding our patterns. Complete the table. We have our blues and our greens. Find your patterns. We've talked lots about looking for those patterns. Find the pattern on your own. Now we have a rectangular prism. Draw a net and label the sides. So imagine that you cut the box up so it can lay flat. Label the sides. Make sure you put the correct measurements on there. The last time, I actually made a mistake with my measurements and I had to redo the full surface area. So given that x equals 3, find the surface area and the volume of the figure. Who remembers what we have to do to find the surface area? Does anybody know the equation? You can actually do the area of each square or rectangle and add them all up to find a surface area. Or you can do you could do the surface area equals, let me hold on real quick. That one doesn't have it. I don't think I've ever taught, yep, I was right. I don't think I ever taught this to you. 2 times length times width plus 2 times length times height plus 2 times width times height. So, watch how we do this. We know how to do a net, how you open it up, and we would have long rectangle, and a long rectangle, long rectangle, long rectangle, and then we've got the short for the sides. So if x is 3, 3 minus 1 gives me 2 for my height. So this would be 2, this is 2, that is 2, and that is 2. So we fold them up. Down here is 5, right? We know how to label all of these sides. This is 9 going all the way down, right? We know how to do the net. You could use the formula to find the answer to the surface area. Instead of finding all the each individual areas and adding them together, you could actually just use the formula. So this is our length, this is our width, this is our height. So you do 2 times our length times our width plus 2 times our length times our height plus 2 times our width times our height. That is your surface area. Multiply, Perm does. Do your multiplications, then do your adding. It's kind of a cool formula to use. I've always just done the finding the area of each individual part and adding them all together. When you have a rectangular prism, you can use this formula. Only for a rectangular prism. Won't work for a triangular prism. Okay? This is for a rectangular prism. But you still have to draw your net and label it correctly. Does everybody understand that formula for the surface area of a rectangular prism? So the reason why that works is because we know with that rectangular prism, we have 2 of these, we have 2 of these, and we have 2 of these. So it's 2 times each of those rectangles.
You meet after school with Ms. Kraler, and if you participate in after-school tennis, you will be meeting in the gym today. If you do after-school tennis, you can go to the gym. Thank you.
Okay, let's look at our next page.
Don't we also have to find the volume?
Oh, yep, and the volume. How do we find the volume? What is the formula to find the volume? Length times width times height. So our surface area volume is 2 times length times width plus 2 times length times height plus 2 times width times height. Volume is length times width times height. You need both. So 2 answers, one for the surface area, one for the volume. There's 2 answers for that page. All right, let's see how well we remember our formulas. What is the formula for volume of a rectangular prism? We just said it. Length times width times height. What about for a cube? Side cubed. That is our reminder. It is still length times width times height, but it's the reminder that they all has to be the same number. Each side is the same length. I still have friends turning in packets to me that have 3 different lengths on it. Yeah, if I multiply those 3 lengths, I get that answer for the volume, but it's not a cube, so it's not right. They have to be the same length. Multiply the same number by itself 3 times. Maddie.
So then I have a question. Oh, never mind. Actually, I realized that was. Never mind.
All right. What about a triangular prism?
Length times width times height divided by 2.
Yep. Length times width times height divided by 2 or times a half. They mean the same thing. Because a triangle is half of a square, half of a rectangle. So it's the same formula, but you divide it by 2 because it's half of it. What about a pyramid? Here says it.
Length times width divided by, so use it times 3 or that is
It's not going to be times 3 because it's a pyramid. So it's,
divided by 3?
let me,
Divided by 3.
yep. Because they're triangles here. That length times width times height divided by 3. Or times a third divided by 3. What about the volume of a cylinder? How do we find the area of a circle? Pi r squared. Now it's a cylinder, Naomi. What do I do? times it by the height. So you've got that circle area times by the height. Pi r squared times h. What about the cone? We've got that circle, so it's pi r squared
Divided by 2.
times our height, but it's like a pyramid because of that triangle, so we're going to divide it by 3. Yep.
Isn't that 4/3 pi r cubed?
Yep. So for the sphere, it's 4/3 times pi times r cubed. The cone is pi r squared times h divided by 3. Are we good if I erase? You can always watch my video later. We only have so much time. So if you didn't get it all, watch my video later. Okay. Woo! Fibonacci's and Pascal. Oh my, bringing stuff together. So, lines have been drawn showing the shallow diagonals of Pascal's triangle. Write the sum of each shallow diagonal at the end of each line. Left side or right side, it doesn't matter. And lo and behold, what is hidden at the end of the shallow diagonals? So what does it mean to find the sum? I don't know why it's staying blurry. What does it mean to find a sum, Leah? To add them together. So you're going to look at the shallow diagonal and find the sum. So that first one's easy. 1 plus nothing is 1. Then we have 1 plus nothing is 1. Then we have 1 plus 1. And then we have 1 plus 2. So you're going to be writing the sum of all of the numbers in that line. Leah. So it says, lo and behold, what is hidden at the end of the shallow diagonals? So do it and see if you can see what pattern there is. So see if you can find the pattern of the sums. So you're going to write the sums out and you're going to see if you can find the pattern. Did you write all the sums out yet, Leah? I'm going to let you just sit with it for a little bit and see if you can find it. Okay? Let's just quick go through it. I only have a couple minutes and then we can come back to it. Oh, mean, median, and mode. We know mean, median, and mode. You should know that off the top of your head with my not having to review it. Polynomials we know how to do. Consider the data and answer the questions for your class. So create a graph that represents the data shown for 2 types of your meat choice. Be accurate, be neat, and use correct labeling on your graph. Tell me what the bottom is. Tell me what the side is. Tell me what these numbers mean. Use correct labeling. What kind of graph do you think we would want to do? A bar graph. That would be easy. So tell me what it is on the bottom. Tell me what it is on the side. You can use that backside for your graph. So you can use the backside. All right, let me stop for my friends listening at home. We hope you are well and hope to see you soon.